Hello and welcome back again to the Coding and Programming Bootcamp. Hello, Nora.
Hi.
In this episode, in this video, we are going to go over the functions chapter, or more precisely, the solutions for the exercises in the functions chapter. So it's your turn. Show the screen and let's see.
Yeah. Let me share it. Okay, so you can see my screen now, right?
Right.
Is the font size okay?
Yes, thank you.
Okay. So we had a couple of exercises here, not too many, but they took me a long time because apparently recursive thinking is something very difficult for me.
Okay.
The first one wasn't recursive though. The first one was a statistics exercise where we had to make a function that takes an arbitrary number of numbers and then returns the sum, returns the average, and returns the smallest and highest element of these numbers.
Okay.
So yeah, this was, I think, pretty straightforward and simple, I would say.
By the way, so just it was an exercise, but I think there is so if I remember correctly, there is a sum function in Python. And probably there is either a min or a max function, so you don't have to sort them.
Right.
I think either there is a min and max function in Python or in the mass library.
Right.
So and then you don't need to sort because sorting takes a lot longer than going over the values even twice, right?
Right. Okay.
So, but it was just an exercise.
Yeah,
and especially it was an exercise of being able. Actually, okay. So what are you returning here?
I return a list of these numbers or values.
Yeah. Okay. So I think my idea was to return the individual values, and then you just get back a tuple, or would be able to assign that to 4 separate variables.
Right. So this way.
Yeah. So that was sort of my idea.
Okay.
And actually, let me show you now something. So okay, now replace the print is so to copy these four variable names for the outside as well, and replace the print with it. So assign the statistics directly to these 4.
What do you mean?
So instead of the print, just type in the 4 variables and then equal, and then you can remove them. So it's just so the fact that we are using the same names outside and inside is just to confuse everyone. They are not unrelated. Okay, so the sum outside and actually, so that's the thing. Yeah. Okay. So yeah.
Should I call them different variables?
There is actually a sum function. So the sum is now overwriting the function, but it's okay for now. Okay, don't worry about it. Don't worry about it. Just okay.
It's less confusing this way, I guess.
Okay, so now you can print them out. Okay, so just print A, print B, but just print A, print B. Okay, let's say. So and then good. And then you can run this function. Let's run this to see that it works.
Okay. Now you cannot see my. Wait a second. Can you see my prompt now?
Yes, right. Yeah.
Yes, great.
CMD.
So it was Python statistics. Wait. What happened here?
It's in the corrections.
Yeah, but it's something.
Yeah,
okay,
that happens sometimes. Yeah.
Okay. Anyway, let's start again. Python statistics, and yeah, apparently works.
Okay, so so the point here, let's go back. That let's say, I mean, you have this function statistics that returns 4 values, but now you have these 2 variables C and D that are not used really.
Yes.
Okay, so and let's say we are not really interested in them. Okay, we can't tell the statistics not to compute them. Okay, because that's how the function works. But now we have two variables, and then people will wonder what are you going to use the C and D here? Okay. Instead of that, you can, well, one thing that people might think, okay, well, so just assign to A, comma B, but that won't work because Python will complain that the function returns 4 values and you're only accepting 2.
Right.
So there is this think variable, I have no idea with NS, that you can just put an underscore instead of the variable. So replace the C and the D for now with just underscore.
Like that?
Yes. So this is like it's a sort of a placeholder of a variable. So now Python will be happy. Let's run it again to see that it will work. Maybe we should have executed the one also removing these two locations just to see that it fails, but trust me on that. So the thing is that that now, because we just put placeholders there, so Python will be happy knowing that you accept the 4 values, but the last two are just thrown away. And let's say you wanted to have only the first and the third one, so you could replace the B with the underscore and put the variable. So you can put it in every place. It doesn't have to be only at the end.
Right.
Okay, so let's you can replace that with an underscore, let's say, and put the B there.
B.
B, yeah,
right.
It doesn't matter.
Right. It doesn't
totally no meaning now.
Yeah.
Okay, so
right.
it is the other thing. Okay, so yeah, that's what I wanted. And of course, I'm sure you're aware that if someone passes an empty list, then this function will raise an exception, right?
Yeah.
Because the len will be 0, and then we will get an exception. But if this is something that you know that no one will go that way, then it's sort of okay.
Right.
Okay.
Shall we go on? Shall we go on?
Yeah, let's go on.
Okay. Next one was the recursive exercise, where we had to, there were a bunch of files with dependencies, and then we have to process them.
Okay.
Yeah, so this was my function that I made for that, which was, again, this gets something. I named it chemical because obviously that's what we were talking about, and that's how it was easier for me to comprehend. So it gets something, a name, it prints out processing that something, and then I said this could be a file name. If it is a file name, then later I do stuff with it, but I just put the name of the chemical here at the end.
Sure. Sounds good. So you,
the thing is,
build the file name from basically a template, right?
Yes. Yeah. So the thing is that obviously, if any of these files are in another folder or in another location, I won't be able to detect that. But I didn't know how to handle that here.
Yeah, we haven't learned about file system and
not that much. So yeah, then I try opening the file, and if I manage, then I read the lines, each line of the file, without the new lines at the end, and then run the same. This is the recursive bit. I run the same function on that particular line. Yeah. But if it doesn't work and it gives this error, which I looked for from the error or exception hierarchy, if it cannot find the file or it cannot open the file, then I just say return.
Yeah.
And then at the end, the script itself, I just check whether there is a argument, a command line argument. If there is none, then I exit saying that we need a starting chemical. Otherwise, I take the second one from the command line and then run the whole function on it.
Okay. So this is a recursive thing. How will it stop? When will it stop? The recursion down the rabbit hole?
When there are no more requirements anymore.
Yeah. So basically, we assume here that That's like a tree-like structure, and there are no loops in there.
Yeah.
And then you get to the end of it somewhere. Okay.
Yeah, hopefully.
Fair enough. I mean, there are many structures that behave like that.
Yeah.
Yeah. Okay.
Yes, and then I did the same thing with just adding something else, which I added a list that collected all of the requirements, just so that you could print, just so I can have something to return at the end of the function.
Okay.
So this is just simply a list of all of the requirements, all of the dependencies. The only difference that I had to make was to append the recursion instead of just running the function again.
Right. Okay. Actually, this would be the right. So this might be an interesting point here, and maybe I should give this as an extra exercise later on, to take the same problem and try to solve it now with a queue, and try to solve it with a with a queue or with a stack.
Right.
Without recursion.
Right.
Okay, because basically you could do the same without having recursion, and then you can compare which is more interesting, which is more clearer, and so on. Okay.
Once I actually got what the exercise was about, this one was easy with recursion, I think.
This was what? Sorry.
This was easy with recursion, I think.
Okay.
Once I actually understood what the exercise was about.
Okay. Yeah, maybe I should clarify.
No, it wasn't. It's not hurtful. I mean, you explained it, so after that, I was okay. But
yeah, okay.
Right. So the next one, we actually had the Tower of Hanoi, but I just couldn't do that. I think I would need a lot more time to do that. I would have to think that through more. So I skipped that one. I did the sorting exercises instead, or not instead, but I did the sorting exercises. First of which was the bubble sort. So here I just had a default list of numbers, and I also calculated what the highest index would be, which is the length of the list minus 1, because we started from 0. And then I created a function that would take the name of the list, so the list itself, and then the highest index, which I also calculated before. And if this highest index is 0, then I just return the whole list, because then there is nothing to sort.
Yeah, that's an empty list.
But if it's not, then I took this loop saying that, okay, for any number between the range of 0 and the last index, check the first and the second, then the one after, and if the first one is higher than the second, then just assign them into each other. Otherwise, just go on and take the next two numbers, and then after this, I just printed for my own, so for debugging or something, and then I would return the same thing, because if you do it just once, then the first, like the highest number bubbles up to the top, but then the rest wouldn't all be sorted. So you have to.
I don't. Okay, so you have to pass in, and now you are passing a list and the number which is
shorter than by 1.
Okay.
So it will stop when it gets to 0.
Okay. Okay.
That's why I had to put this condition in.
Interesting. I mean, I guess you don't need to compare it to 0. You could compare it to 0 or 1, right? If you have one element, then you don't need to. You don't have anything to do either.
Yeah, that's true.
Interesting solution. So
I mean, if I have one element, because this is the index, then it would be 0. because this is the number of the index, not the length of the list.
Okay. So there might be two elements in the list. If the max index is 1, that could be the second call, or the recursive call.
Yes. So if there are two elements if there are 2 elements in the list, then the highest index would be 1.
Yeah.
So when I pass it here, it would still run because the condition doesn't catch it because the highest index is 1.
Yeah. So now I'm thinking, actually, I wonder how I solved it, but I'm thinking that maybe bubble sort, even the standard solution of bubble sort, maybe not recursion. I'm not even sure.
Maybe.
But I think that the solution would be the good recursive solution would be something like, okay, we have an n element list, so take n minus one element, call the recursion, call bubble sort with itself, with the shorter list. It returns a sorted list, and then take the element that we are left with, and find its location by going into all the elements.
Okay.
That would be probably, I'm not even sure actually that that's called bubble sort. I'm already getting confused with all this sorting.
Yeah, it is very confusing. This took me a long time to figure out how I could do it.
Okay.
But yeah, this is what I came up with. I don't know if it's very good or not.
I don't know, but let's go. I mean, we don't need to spend more time on it because I don't have like a perfect solution here.
Right. Okay. There was just one thing that I tried and then spectacularly failed with it, with this with the bubble sort. I tried another one where I didn't have to compute the highest index. I tried to put that into the function as well. Okay. But then I had to use this, which is obviously defeats the purpose because I used the sorted function already. But yeah, so I was just trying to figure out how I can put the length inside the function, so I wouldn't have to compute it outside.
Yeah, I mean, that's what one of my first thoughts was, not to calculate outside, but then you said that you're calling it. Well, interesting. I mean, if you go back to the previous solution, then it's a bit strange because the first time, no, every time, basically every time you call it with one less. The first time also you call it with one less, so you don't really need that. You can calculate the max index inside the function, right? Because it's just the length minus 1.
Yes, but that was my problem. So the length is going to be the same every time, the length of this thing. So I start with 0 as default.
Oh, because okay, so maybe because you have to pass in a shorter version of the list.
Yeah, I could do that. So should I should remove whichever.
Just send in the slice, that slice from the beginning, let's say, to the n minus 1 element.
Right. So
in the recursive call, and on line 14, put in square bracket and 0. You don't even need the 0 there, just colon or.
No, wait. The first element is going to be the one that's smaller anyway. So I don't need the very first element. I need the rest.
Okay. So
no?
I don't know.
From 1 to the end.
Okay. And then you don't need the. So let's do this way. Okay, so you call it you call bubble numbers from the beginning, at the beginning, right? That's the bottom of the code.
Yes.
Line 16.
Yes.
And then the top line 3, you don't need the L equals 0. Okay, we can remove the whole thing. Okay. So you get num, okay, or nums. Let's go with nums, so whatever. Okay, because it's plural. Okay.
Yes,
So,
okay.
and then what you do is that check if the nums. So first of all, if the nums, you don't need this sorted thing. So you check the length of the nums.
Yes, okay.
If it's less or equal than 1. Okay.
Okay, so if then nums less or equal than 1.
Yeah, then just return nums because you are done, right? If you have no element or just one element, then you are sorted.
Yes.
Okay, and then now we are doing the recursive thing. So let's do it this way. So put in first, and so like just put in the word first. Yeah, it doesn't matter which side actually. I don't know. So first equals to, and then remove the first element from nums.
So that's what?
You can just put nums square bracket 0 here.
Oh, okay. So I don't need to actually remove it.
Yeah, I don't. Well, let's not remove it, and then call. And the next line, let's be rest equal to bubble nums, the rest of the nums, right? So from 1 to the end.
So the 1 to the end. Okay.
Okay. So this is basically the whole recursion. And now what are we doing with the first? So with the first, now we have to go over all the elements. So rest is now sorted.
Okay.
Okay. So let's just comment out the rest of the code for now. Okay. So just so you can think about it. Okay. So what we just said is that we have the stop condition. Okay. If the list is short enough, empty or one element, then we are done. Okay. We return the list, and then we say, okay, for every other case, take the first element out, sort the rest. Okay. So now if once we are done with the bubble function, then this will work, right?
Yes.
So assuming that the bubble function already works, then this works. Okay, so rest is going to be sorted already. Okay, so now what do we have? We have a sorted list and a single element.
Yes.
So now we have to look that we don't know where is it should be.
Yeah.
Okay, so now we have to go over all. There are a couple of ways actually. One of the simple way is to go over all the elements of the rest and find the location where where the first should be. So now you can go over, comment out so now you go over the elements, the indices actually. That's a good idea to go over the indices of the rest.
Okay. So
for I in range, and then you can put in len of rest, right? And then you compare the element of rest in the i's location,
right, to first.
To first.
Okay. Wait. So if
with the pro, yeah.
So first is higher than what is it? Rest I.
So we have to decide: are we okay? So yeah. So are we putting increasing order or decreasing order?
We should probably go increasing, no?
Increasing order. Okay. Yeah. So if you go over, when you encounter, so when you have an increasing order of list already, that's the rest, right? And then you take the element, and if you compare it to an element, and you notice that it's still S. I mean, once it wait, no. So you assume that the first is smaller. If the first is smaller than all the elements, right? Then you put it in the first space.
Yes.
But if first is somewhere in the middle, okay, then you will have a couple of elements where the first is less than the rest.
Yes.
And the first time, okay, when the first is bigger than the rest, then you know that you have to insert it.
So it shouldn't be if, it should be while, isn't it?
No. Well, no, you already have the loop.
Yeah, okay.
And then you say, okay, if the first element is smaller than the rest, than the current version of the rest,
Right.
then you don't do anything because you're looking for its location. You're looking for the first place where it is bigger than the current element.
Yes, okay.
So you have to turn around the operator. So when first is bigger than the current element of rest, then insert the value instead of in the I in the current location.
So that should be rest I equals first.
Well, that would replace the i's element.
Oh, that would replace it. Okay, so how do I insert it?
Rest.insert.
Okay. Of course.
And I think it's I and first.
I and comma first, right? Like that? Is that right?
Yeah. And if that's done, then we are done with the operation, right? Then we found location of first and we inserted it. So we can break up.
We just.
Now we still need the else part, but not there.
Okay.
So, but that's only if the condition you met the condition, right?
Yeah.
Because so if we found the location, so we go over the elements. If we found the location, then we insert the element right there. Okay.
Yeah.
And if we went over all the list and haven't found the location yet, then we have to add to the end of the list. Because the first element then is bigger than all the rest of the elements. So you already have an increasing list.
Yeah, but then at the very end, when it gets to I that equals to the last in, oh, actually, this should be -1, right?
No.
No, or I should remove this.
Yeah, that doesn't matter. But yeah, it's clearer without it.
Yeah.
So you have, okay, so think about it. You have a list, increasing list, and you have an element. And you start looking, where does it fit in? As long as it's smaller than the current element, you keep going. Once it's bigger than the current element, then you insert it there.
Yeah.
In front of it, actually. Okay, so and you push it away. So that's why the insert works. But if you went over all the elements and the first is still bigger, it's still bigger than all the rest, then you have to put it there.
Okay, but then wouldn't this insert it, or should then?
Then you have to have at the end of the for loop, you need an else. Not in the case of the if. At the end of the for loop.
At the end of the for loop.
Yeah. So because now you have to know that I think we talked about it once, but it's a rather difficult concept, that basically you have to know if the for loop ended because of a break or because you went over all the list.
Yeah.
Okay. And the else block in Python allows you to do that.
Right. So here.
You say you can, yes. Okay. So this will be executed only if the for loop went
it's
over.
Done without, yeah.
If it done the whole thing. So now you can rest.append the first element. Okay. And at the end we just return the rest.
Okay.
Okay. Let's try. Let's see if it works.
Okay. We're here, and then Python double sort 2.
Okay.
Oh yeah, I didn't change.
some place where we have num. Okay.
The rest should be fine, I think. Oh, we didn't call it yes because it returns.
And we didn't print it.
Yes.
But I'm already happy that it ended at some point, so it's an infinite loop. That's already something good. Okay, so except that we managed to do it in
the reverse order, yeah.
Yeah, so okay, let's try it. Let's reverse the operator there.
Yeah.
And see if that works.
Yes, great.
Okay, so everything looks fine now. So basically, this is somehow probably the way I would think about a recursive solution. So sort of, oh, let's assume that it already works, and let's use it now.
Right.
Okay, and then think, okay, assuming that it can do it for a shorter version of whatever, then how do we solve it?
Right. Now, I don't think that this is actually a bubble sort method anymore.
I'm not sure either.
It is a sorting method, but not sure if it's the bubble algorithm.
Right. One thing that I'm quite sure is that once we have a sorted version there, it's faster if we are using a binary search looking for its location.
Right. Yeah.
So instead of going over all the elements, we should look in the middle and then half it and then half it, and that would be faster. Okay.
Okay.
Okay. Good. So, but we have something that works.
Yes, that's true. Should we go to the next one?
Yes.
Okay. So the next one, actually, I couldn't finish, which was the merge sort. I did something and then it doesn't quite work, but I didn't manage to figure out what's wrong with it.
Okay.
So I'll show you how it runs, and then maybe you can tell me what was the problem. Now this was the merge sort method or algorithm, or I don't know how you call it, where I had this list that I wanted sorted. So first of all, I had to split all of the lists into like halves until I get.
Let's quickly explain the merge sort, right? So
merge sort works in a way that it gets a list, it separates it in half, and then separates the sublists in half as well until it gets single numbers. And then when it gets the single numbers, it compares two of the first one that came from the same double. It compares them to each other and then puts the smaller one back first, and then the second one back first into the double that it was split from.
Okay. Let's try to explain. Okay.
Actually, it's probably like this helped me a lot when I was looking at this video here on Wikipedia. So obviously it splits everything up and then takes the numbers in the same order back.
Okay, so I would explain slightly differently, and maybe the explanation helps on how to figure out the recursive algorithm. So what I would say is that I have a list, okay, of elements. I split them at the middle, sort both of the lists,
right,
and then merge them together as they fit together,
right,
the elements,
right.
Okay,
so you would just say this last step.
So I wouldn't, in the description I wouldn't go down to, okay, I'm splitting up to the one piece.
Okay.
I mean, maybe that's how we start. That okay, given a one element list, I don't have to do anything because it's already sorted. For any longer list, I split them into half as much as I can. So maybe if it's an odd number, then one of them will be longer. Okay.
Yeah.
Sort both of them using the same thing, but now we have shorter lists to sort in both cases.
Yeah.
Okay. And then go over both lists and pick always the smaller one from the two
Okay.
lists, and that's how I merge them. Okay,
Right.
let's look at the algorithm now, the solution.
Okay. Right. So the first thing I did was to do this splitting thing,
Yeah.
to split them in half, and I created two sublists or slices,
Okay.
like this, and then I said, okay, split those slices as well. So this is already recursion, and then after that I called this function, which I only made later on in the code, which would merge the two lists that we just made here into one, like sort them into one list. Yeah. So the way that merging works was the interesting bit, which eventually didn't work apparently.
Okay.
So how it works is I had to put a while loop here so that I could go over. I could only consider the times when both of the lists have at least one element in them.
Right. Okay.
Because if they don't have any element in them, then I do something else with it. So here I created a list which I called merged, an empty list, and then here actually I didn't need both of the variables. Sorry.
No, you're using both.
Sorry. Yeah, but I don't actually need to use both, I think. Anyway, it didn't work anyway, so we're gonna have to
okay. So
figure out why.
shall we go over this, or shall we start writing our own version?
Do you want me to go over this?
We don't have to.
Okay. Then.
Okay, so let's try to write our OR. So maybe comment out the whole thing, so we'll still have it here, and then.
I'll just make a new file.
Okay. So then let's do these explanations. Okay, so have a list and then call merge sort or whatever.
Okay, so do you want me to define the list now, or?
Yeah, just call merge sort or print merge sort and the list. Basically, that's what we.
And the list.
I'll give it just a list. Okay, and then create a list. So we have.
I don't know.
Okay. Something good. Okay. So before that, before the calling, we have to define the function.
Yeah.
So okay. So now you can define the function merge sort. Well, but it's better not to call it list because that's already a keyword. Yeah, good. So now what we said, right? That if the list is empty or has one element, so if the len is less than or equal 1, then we just return it because then we are done.
Yes.
Okay, so that's what we call the stop condition. Okay?
Yeah.
For every other case, we split it into 2. So now you can copy actually from your solution because it's the splitting part, not the whole function, just the internal part. So the half and then those 2. Yeah, those 3 lines. Yeah. Okay. Okay, and just okay, and now, but you can already call the recursion on this, so you can merge sort both of them. So the list one first half, well, you can do it separately if you would like.
Merge sort x.
Yeah, and you assign it to some variable.
Okay. What should I call it?
I don't know. XX, YY, I don't know.
Okay.
Sorted X.
Yeah. Okay.
Okay, and now we have to combine the two. Okay, so now we have, if the merge sort already works, then this will, or we already have two sorted lists.
Yes.
Okay, so now we have to merge them together.
Yeah.
And how can we do that? We go over the index of from 0 to the shorter one, I think.
Yeah. So this is where I put in the condition that I only do that if both of them are bigger than 0.
They are both bigger than 0. Otherwise, you wouldn't get here.
Right, but if I start, yeah, okay, fair enough.
Right, because if there are less than 2 elements in them, okay, then the first the line 4, 5 already returned it. You won't get here. And if
right, but that's the original list.
Yeah,
but
no, it doesn't.
If you
There's no original list. We get a list. It doesn't matter what length. Okay.
okay.
If the list is so for now, forget about the fact that you put it in a list with 7 elements. Okay, that doesn't. I don't care. Okay, you just get a list. If this list is short, okay, 0 or 1 element, then you just return. Okay, done. You don't do anything. If it's 2 or more elements, then we split it into 2 parts. Each part will be at least 1 element, right? Because we had 2.
Yeah.
So,
Okay.
so by this time, unless the merge sort itself eats elements,
Okay. Yeah.
I mean, we assume that it returns the same number of elements.
Yeah. Okay.
Okay. So both of them have at least one element. Okay. And then now we have to merge them together. So now we have to go over the index of the
but which one? We don't. I mean, it's usually the first half that is the shortest if there are uneven numbers.
Actually, that's actually we can use this. So the short is the first one is the short always.
Yeah. Well, yeah, because you call up to the middle and then from the middle, and if
okay. Okay, so I think we go over that one, and then we compare. Well, actually, we need 2 indices actually.
Okay.
Because we are going over the 2 lists, but not at the same pace.
Yeah.
Okay, so we need. So maybe it's no, not that way, because we don't. Right.
That's why I tried using the while loop.
Okay,
my solution.
So 4 probably doesn't fit here because we don't exactly go over. So we have to create 2 indices. So 2 variables, I and j, both with 0, starting with 0.
Okay. Should I already put that in the loop?
No. It's outside of the loop. Because that's like the beginning. And then you say the loop as long as the I is smaller than the length of X sort and the J is smaller than the length of the other one.
While is smaller than X sorted. Why not just X?
Doesn't matter. They are both the same length.
Yeah, but then, okay, you just, I thought that you said this specifically for a logical reason. Why you think this comes easier?
Sorry, I'm not sure. I didn't understand the question.
So I just thought that you maybe said X sorted instead of X for some like logical reason because it's easier for you.
No, but we are going over the X sorted and the Y sorted lists. So, but they are the same length as X and Y here.
Yeah, okay.
Okay, so as long as they are both shorter, then we compare the 2.
Okay, so X sorted I. Okay, this should be a condition, right?
Yes. So if the X sorted I is less than the other one,
Y sorted.
right? So we go over 2, then we need now a place where we collect the sorting. So we need a list where we're going to be collecting the merged. Okay. Okay, so you append the element to the lower element. And now you have to move ahead, the increase I, right?
Yes.
And otherwise, you do it on the opposite. So otherwise,
Yeah.
you take the one from the Y and move it there. And I wonder if that's enough.
Okay, but what happens now if they are not the same length? Because now they both have to be.
No, they're just increasing.
Okay. But if there is a. Aha. Okay. Okay.
Okay, and then you just return the merged list.
What happens when there is, like, when Y sorted is one item longer?
So I hope, I haven't thought about this through, but when I mean, in the end, it doesn't. I mean, the question is important, but the way they work is that one might progress one much faster.
Yeah. Yeah. No, I get that.
Sorry.
Yeah, I get that, but
so
okay.
When the I reaches the end of the X list, okay, because those were the smaller elements, then all the elements on J will be now bigger than the current element of I.
But how do you append, like, the rest of the remaining list?
Yeah, so that's okay. So that's okay. That's the issue, right? You're right. So when we reach the end of one of them, then I will be, let's say, reach the end of the X list. Okay, then and J's, then the Y list still have elements. Then we don't go over them. So we still need that case outside of the while loop, I guess.
Yeah.
Seeing now if which one reached the end, and the one that didn't reach the end, I mean, one of them will reach the end. That's why we stop, right?
Yes, yeah.
So now you check which one didn't reach the end, and you take all the elements from that list and append to the end.
Because they should already be sorted.
Sorry?
Because they are already sorted.
They are already sorted, right? Yeah. Because we got them back from merge sort.
Yes. Now this is what's difficult for me. Okay. So
yes.
How do we check which one?
So you compare now. You compare I to the len.
Okay. So
Len of X sorted.
If I is.
It's still is smaller than the len.
Smaller. Yes. Okay. But then we don't add the other condition, right?
You don't need the other condition because. Okay. So if the I is shorter than then you take the rest of the elements. No, this is you need to extend here.
Oh yes. And then just say X sorted, right?
X sorted from the I.
Yeah. From I
to the end. Okay, just a colon from the if statement, and then you also need an else statement here, right? For the other case.
Oh
Yeah,
no,
I don't think I have the solution actually in the slides. So
we need a different one.
Why?
Because we are not using the same.
No, it's okay. It was okay, I think.
Yeah, okay.
Well, we might still need a condition, yeah, but I think I think this should work.
Okay. Should we run it?
Let's try it. What can go wrong?
Okay. What did I call this? Merge sort.
2.
Nice.
No, it did something good. Okay, now you can try it with some other lists. You can add more elements, or just to make sure. You can add yeah, no, just yeah. So just make sure. Okay, well, enough. Okay, just remove one element because of the oddness and.
Okay.
Okay. Still works.
Yeah.
Okay.
Nice.
So but this is like sort of the way of thinking. Okay, try to think. Okay, let's assume that it works and use it.
Okay.
And then yeah.
Yeah, this is hard for me to think that way.
It took I don't know. It took me ages to figure out. Okay.
Yeah.
Or to be able to do something. So don't put it on one hand, and on the other hand, it's not that often that you need to implement something recursive. Okay, and in many cases you can do it, replace the like what I mentioned earlier, that you can replace it with using a loop, a simple loop and a queue. Okay, to hold the things that you still need to do. Okay, I think merge sort is specific in that it's like ideal for recursive sorts.
Recursion, yeah.
Yeah.
All right.
Okay. Do you have more?
No, this was the last exercise here.
Okay. So I remember I added it later, but I remember that I also mentioned that take all kind of exercises that we already had and convert them into functions. Did you? I guess you didn't do any of this, right?
No, I was busy enough trying to figure out how recursion works.
Okay, no problem. I really recommend that you do that.
Okay.
You take previously solved. I mean, okay, let's do this now. Okay, let's just go on with the merge sort. Okay, maybe create a copy of it so we have the working version.
Okay.
And let's just take this one. Okay. And now, so this is a long function, right? So let's take out the. So what part of this do you think that could go into a separate function?
Well, how I did it before was to have this splitting bit separately.
Yeah, but that's the recursive part.
Yeah.
So you can take all the rest. So line 13, basically.
So the actual sorting and merging part. The
merging part is here.
Yes.
Okay. The recursive part is in the merge, and this is just. And so now what you do is you say, let's say, return. No, yeah, okay.
Like this should be another separate one, no? This could be a separate function.
Yes.
Merge, I suppose.
Yeah, you can call them merge.
And then it gets 2 lists.
Okay. Yeah, okay.
Oh, now I should call it X sorted and Y sorted.
For now, call them X sorted and Y sorted.
Yeah,
Later
so
on, you can replace these names with something else. But for
yeah.
now, call it X sorted, Y sorted. Okay, so now you moved it out, and from the main function, you need to call this.
Oh yeah. So here I just need to say merge X sorted Y sorted.
And return whatever it returns, return yourself. So you don't even put it in a temporary variable. Looks
Like
good.
that.
Okay.
Okay.
And now you can try to run it.
Merge sort.
2_1, I think it was.
Yeah. 2_1. Nice. It does what it did before.
Yeah. So by just this small change, okay, this was quite easy because of the way it was written already. That was separate ideas were separated, but basically now you have two separate functions, and you can separate. You can now test or check or whatever the merging part separately. It
Yes.
doesn't have to know about anything. It just gets two lists. You can rename the variables inside, and it just gets two lists, and then you can check whether that works on its own.
Yeah. Okay.
Okay, and when you need to read it, understand it, you can understand it. Okay, and you can, and also if you go back now, then the top part, the merge sort part, reads a lot more like the recursive algorithm.
Yes.
It now
Okay.
say, okay, split it into half, merge them, sort them both, and then merge the two together.
Yeah. Okay.
And then you are hiding the actual work.
Yeah. Okay. Yeah.
Okay, so if there's no more exercise and more questions, then we can stop this video. And okay, I still recommend that you do and go back to various of your exercises and try to do this, because it's on the long run, it's very good for your programming skills and for and reading code. Now if you go back now to the earlier exercises and you have to go over them, that's itself a good thing to be able to read your code.
Okay.
Think how you could improve them. Okay.
Okay.
Okay. So see you in one of the next videos.
See you.
Bye bye.